Hi folks, Mr. Long here for the fourth screencast in a series of 4 screencasts. So it's the last time you'll be hearing from me. I'm sure, thank goodness, on your part. Okay, so in the last question, and the question is number 4 down here, but I think it's probably much easier to talk about it verbally, or to go over it verbally. Our goal in this question is to take g of x and make it overlap f at x. Well, if I'm taking g of x and overlapping f of x, that means f at x is my original function. Okay, so I'm going to do what operations do I apply to g of x to get it to overlap f of x. Now, what we should do before we start this mathematically is get a feel for it. What things should the mathematician notice? Well, I see that this, the original, opens down. The transformed opens up. What does that tell me? That there's a vertical reflection. A will be negative. Okay, what else do I notice? Well, if I look at the really, the short branch of the figure, it opens to the right. The short branch over here opens to the left. What does that tell me? It's a horizontal reflection, and K will be negative. Okay, what are some other things? I need to look for the invariant point on the original. Invariant with respect to multiplication and division. So 0, 0 is the best point for that. So if I'm at 0, 0, whether I multiply or divide by A or K, I'll get no change. Okay? Now the other thing I want to remind you of is when we're trying to get something to overlap the original, that's an inverse process. So we need to undo addition and subtraction first, and then undo multiplication and or division. Okay, folks? So what I notice, again, I'm going to put a mark over here. So that's my invariant point right there on the original. Well, what's that correspond to? Right there, that point. Okay. Now, a couple other things I should do is check my height and width. So, and I'm going to do it in this general transformation. I'm going to do this for specifically this simpler segment here. Okay, so that segment there corresponds to this segment. Now, what I do on the original function, I treat all heights and widths as positive, okay, because it's the original function. With heights and widths, it's really just a number, right? And then all I'm seeing is on the transform version if it goes in the opposite direction. And then I would have it as negative. Okay, so let's go through this. So the first thing I notice is that the height, delta y, for this segment is 4. The width of the original is delta x, and that is 2. Let's now compare that to the transformed function. And again, in terms of corresponding, this side here corresponds to that side there. So now I'm going to do delta x and delta y. That distance there is delta x. Notice that it's 2 units away from the vertex to the right, whereas this one is 1 unit to the left. So delta x is -1, okay? It's opening in the opposite direction. Now let's check delta y. That would be from here to here. And delta y is 4. Now, is it a negative? Well, if I look at the original function, I have the vertex at the top, and I come down. Over here, the vertex is at the bottom, and I would go up. So that's negative. Okay, it's just negative means opposite. Okay, so now I've got delta y and delta x. So let's go through the transformations. So when I'm doing inverse, that means I do add, subtract first, then multiply, divide. So first thing is I need to get the invariant location overlapped. So that point corresponds to that point. What do I need to do? I need to 1, 2, 3, add 3 for x, and I need to 1, 2, 3, 4, drop y by 4. So add 3 to x, drop y by 4. So let's take a look. If I'm adding 3 to x, plus 3 to x, and I need to minus 4 from y. Okay, and what that does is it makes the invariant points overlap. Okay, so now I can undo multiplication and division. So if we look at the height, what mathematical operation changes a negative 4 to a positive 4? Dividing by negative 1. But we already knew the a value was negative because there's a vertical reflection. Okay, so I'm going to divide that by negative 1. No change in height, but there's a reflection. Next, delta x. Delta x is negative 1 here because it's the opposite direction of delta x over here. So delta x is positive 2, delta x is negative 1. How do I turn a negative 1 into a positive 2? I multiply by negative 2. Okay, I'm starting with a transformed, and I'm making it overlap the original. So I need to multiply by negative 2. Okay, and that's the function. Now I need to get y by itself. What inverse operations will I need? Well, I have to multiply by negative 1. That will get rid of that. And then I have to add 4 to get rid of that minus 4. My overall equation is then going to become y equals negative 1, or just the negative sign is fine as well, f at negative 2 bracket x plus 3 end bracket, and then I have to do this plus 4. And that, folks, is the transformed version or the transformation equation to change g of x into f at x. Or rather, to change f at x into g of x. Oh, by the way, probably instead of y, I should have had that as g of x. Okay, I don't like using, on the left side of the equation, I don't like to use g of x for some reason. I prefer to put a y in there, and then, but I have to remember to add g of x at the very end. Okay, folks, so pause, rewind, go over that, but that's the process. Have yourself a great day.